Hi, my name is Carly Byron. I'm with the ToF group at the University of Delaware, and I'm going to talk briefly about the ToF SIMS instrument that we have in the surface analysis facility. So just to give a very brief overview, ToF SIMS stands for Time of Flight Secondary Ion Mass Spectrometer. It's a surface-sensitive technique where you bombard the surface with an ion beam. And then those beams, those ions hit the species on the surface, and they eject secondary ions from the surface up through these transport optics. And the mass of the ions that were ejected can be identified based on their time of flight through this tall vertical chamber up here. And those times of flight can be turned into a spectrum of masses. So I have a few pictures here of the ToF SIMS that we have. It's on this sort of desk setup. Here on the left are the computers that we use, where you can control all the parameters of the instrument. There's a joystick where you can move the sample holder around. And then here you can see the sort of vertical chamber where the ions travel up and then down, and you can get the time of flight. This all happens under vacuum here. This is the vacuum chamber. And it has to be under vacuum because so that the ions can travel unimpeded. And then this is like the chamber where you insert the sample. Here's like a sample rod, and you insert it into this chamber first, pump it down, and then next into this chamber. So this is just another picture, kind of a closer up view of all the different things that are connected to the instrument. Most of these are to different like gauges and things like that to maintain the vacuum, which is very important to maintain. And then for just a little look at what the data looks like. This is data that was taken from my coworker, Masa, in the ToF group as well, where you can see, actually, it's a good example of the different isotopes that you can see by ToF SIMS, which is pretty interesting. Where when you have something like platinum, where she was looking at an organometallic platinum species, because platinum has several isotopes that are pretty naturally abundant, you can see each type of platinum on your spectrum. So it can be very specific, down to like the exact isotope that you're looking for. So it's a very interesting instrument. It's pretty cool. And if you come to University of Delaware, this is something that you could use.